Hey, everybody, just wait another minute or two to get going. Hey, still gonna wait another minute or so before we get going, but a question for Usama and for Mark. You two are tentative or are on the agenda for today. I think Usama to continue the discussion from last time, and Mark, if you wanted to solicit any more feedback regarding the TWI specification you talked about recently. Are you guys interested in both doing that today, or?
I can certainly speak to what we're doing in the Trustworthy Workload Identity Group and how this SIG can help.
Mhm. Okay, how about you, Osama?
Yeah, I can finish the discussions. I think I have three discussion points on my list from the last meeting that I would like to discuss. I believe that
Okay,
shouldn't take
cool.
much time, but if you have time, I can then talk about it.
Yeah. Well, the ordering was you, then Mark, and then if there's time, there's another item for brainstorming on backfilling topics that the SIG wants to cover. So I just wanted to get my head straight as for what we'll actually do today. So it looks like we're building approximately the usual set of folks that join the meeting. So let's get going. Thanks everybody for attending today. I know I always get a lot out of listening to everybody talk and get a lot of learnings out of it. Today there's three items, and the first one is a continuation of the discussion a couple weeks ago that Osama was leading. So Osama, if you want to take that one away. Or I guess actually before we quickly jump in there, does anybody have any um, announcements or something they want to um, pipe in here at the beginning before we jump into the kind of usual topics? All right, sounds good, Osama. If you want to share your screen to show the slides and take it away.
Yeah, sure. Thanks a lot. I will share the screen. Should hopefully be visible now. Okay, so yeah, so this we have been discussing in the last meeting, and the new thing is Hank has joined us. All of the people were already there, and I believe Hank is also in the call. So I will just quickly recap, passing through it very fast, not to take much time. And I want to discuss more on the open problems, the three issues that were highlighted, or the three discussion points that we couldn't get at the end of the meeting. So I would like to focus there. So just as a quick recap, TLS versus attestation, we had a discussion on these two trust anchors, CA and the hardware manufacturer. And then as the architectural perspective, combining verifier and relying party roles of RFC 9334, very simplistic view from protocol perspective, I'm going to only talk about these two entities. And that's nice because then I have two entities from attestation side, two entities from TLS side, which I can directly map one to one. And from protocol perspective, this is like integrated attester, everything inside one thing, and a separate environment that is namely the target and the testing environment and the protocol we discussed last time. And a very old picture, attested TLS, we view it now combination of two things in three different ways. From attestation world, where exactly the signing happens compared to the TLS handshake before, in between, or afterwards, from cryptographic perspective, pre, intra, post. And here we have all the design options that have been extensively discussed in the SIG beforehand. So yeah, I will go ahead with the channel bindings that we have for pre-intra post. In pre, remote attestation sends evidence to the TLS. In intra, that's an exporter that goes into remote attestation and evidence comes back. And then in TLS, we have exporter going to the remote attestation. And what we were discussing last time was something like this, which is that the diversion attack within the CSP. So one can, okay, so why I have specifically within the CSP is that one of the diversion attacks was if I don't have any identity associated with the remote attestation protocol, I can divert it to anywhere in the world. And that's what we had some proposals how we can fix, but what is open is how it can be fixed within the CSP. And one open question I will go to that was mentioned by Fritz was that the threat model, we should view it not as fully untrusted, but rather as honest but curious that looks to us like a reasonable thing. But this is a discussion point for um, people to have any comment on, or if there is any reasonable justification that one can argue with fully untrusted threat model, because we don't believe we can solve this problem having this threat model. Keith, please.
So I don't know that we should jump clear to the CSP needing to like sit in the role of an honest but curious place in the threat model. I think viewing the CSP as a untrusted platform as much as possible is still the goal here. I still have some reservations on whether or not the attack that you outlined on the previous slide that we've talked about a couple different times now is a like in scope type attack, or whether or not there is some amount of the threat model that like the CSP machines are fungible, and you are signing on to the idea
Right.
that you can't bind to a
That
particular
was
machine. But yes,
no.
sorry, yeah, you were getting there. But
Mhm.
I don't think that the fact that we're dealing with equivalence classes though does put it into the only honest but curious is the highest guarantee we can give.
Okay, so I would like to put one thing for discussion, that is namely, so from your description, it seems like a goal, and that goal could be a future goal that's not yet achieved. So what we are discussing specifically in this work currently is what protocols do we have at the moment, and not rather that what's the goal that in the long term maybe we are trying to achieve. If you are talking about the goal in the long term, then I am fine with this. Maybe we should try to do that. That's okay for me. But I am talking from existing protocols and existing mechanisms, and in that I am not sure how the existing protocols, namely particularly the ones that we have analyzed, this RATLS and the Internet Draft TLS Attest, which is also a SIG project. Both of them indeed are actually the SIG projects, this interoperable RATLS and TLS Attest. Talking about those, I am not sure how we can solve the
So
problem.
I would say that even now the threat model is
Mm-hmm.
the CSP is fully untrusted. The word fully is a loaded word that can be interpreted a number of different ways. I mean, are we like liquid nitrogen on the chips and decapping them and things like that? Is that in the scope? I think there needs to be some amount of viewing the CSP as being an untrusted environment, but over time the some of the natures of attacks will can change. But I think my point that I was making though is I don't think that the attack you outlined on the other slide, the one with the big A in the corner, um,
Mm-hmm.
I don't I don't view that as violating this fully untrusted environment goal.
Can I comment on that directly? Because I agree with Keith, and I just want to point out, so the honest but curious model, I only brought that up because I wanted to highlight that if you want to go more into formalization, and if you want to go more into, let's say, how cryptographers do things, so a more precise language, you need to come up with a clear threat model. And I think he said it already, or encounters that nudge already, right? That once you say fully untrusted, what does it mean? I don't think it means liquid nitrogen. Maybe it does. I think at that point you need to go into what cryptographers have been doing for generations, and go into a clear threat model. What do you expect the CSP to do, and what do you not expect the CSP to do? And I think the semi-honest model, it will be some sort of semi-honest model in a cryptographic sense, but it will probably not be the honest but curious model as it has been established in, let's say, cloud security domains. And I think it's also totally fair to find your own semi-honest, nuanced model that you highlight, because as far as I'm aware, there is not an established TEE semi-honest model out there. I think there are 2 formalization papers that I'm aware of that go in that direction, but yeah, you need to just find your own definition there and define what is allowed and what is not allowed by the CSP. But it will be indeed between fully untrusted, whatever fully means, or rather, I think fully in any sense, fully untrusted. So it will not be that, and it will also not be the honest but curious model. So you need to define that for
Yeah.
your use case.
2 follow-ups. One, I would like to request if you can put the 2 papers that you mentioned either on Slack or on the chat, so we can follow up with that.
Or in the meeting notes would be great.
Yeah, anything would work, so that would be great to follow up on that.
I have to
And the
find
second
papers,
thing,
now you're pinpointing me on those. I can try to pick them out.
so because I mean, I'm asking this because we had a lot of discussion on this, and by we mean all the people I listed on the first slide, and we couldn't really find something that's from a protocol perspective defines what these marketing claims like fully untrusted actually mean, and how do I I mean, I can formalize it, but that's just the paperwork that we can write nice papers on it. But what we would like rather than writing nice papers is that the CCC has a well-defined formal model, or maybe it's not formal, it's just for me, but maybe it's a well-defined model that is well justified and not just making a marketing claim that, hey, the CSP is fully untrusted. I'm really fully against this, and the attested TLS team that's also almost convinced with this that this is not something that we can achieve with the current protocols that we have. If the CCC comes up, let's say tomorrow, with some new fancy protocol and it convinces us that this is possible, then we are completely fine with it. But the current protocols actually do not do that. And
So I think
yeah,
to your point, Osama, I think it would be good to have a more crisp threat model definition than what it currently exists in the CCC.
yeah,
Because I think that's where the disconnect is a little bit on this. Because I looking at what I would view as like the reasonable expectations of what you could get out of a CSP, the threat model would not include the CSP could schedule you to a different machine as even considered a threat. That's just expected and even desired functionality. But Ari has had his hand up for a bit.
Yeah, hi. I'm also from Google, Ari Feldman. I'm just joining for the first time. I just wanted to, I completely agree with Fritz and Keith that, having a threat model is helpful because, one example, and I don't know if you all have talked about it before, of, like a threat model that's kind of in between, is something I've heard about is like, some kind of non-targeting property whereby, there's an assumption that some of the enclaves are compromised, but not necessarily all of them. And there's, some limitation on how much diversion can actually take place, or the probability that you will be diverted to a compromised enclave. I'm not sure it can be addressed at the level of this protocol, but it's something that I've seen articulated as something between fully untrusted and honest but curious or something.
You're throwing me back 8 years to my master's
So-
thesis. It's always fun. But that's
So-
where
so,
I try to throw in the semi-honest pieces, right? Because you very quickly, so it depends on how formalized or how precise you want to speak, right? Because if you want to be really precise, then you basically go back to the cryptographic multi-party computation semi-honest models, where you end up in a situation where, well, you kind of need some Byzantine style communication protocols, where you need some proper definitions on all of these things, right? And this is now a weird niche where we don't really want to go there, but we also don't fully trust the CSP. And so I think we won't get around to doing some more clear discussions on what for the specific protocol do you need to trust the CSP for. But at the same time, it doesn't, I think, make sense to give a broad definition of this, because there may be different CSPs, there may be different users of these CSPs. None of this will apply generally, I think. So I would be a little bit wary of doing it too broad, trying to draw the scope too wide, because then no one will agree to it anyway.
But we can have multiple threat models, Fritz, so that's for to take into account different perspectives. Let's say for one for something and one for something else, but at least we should get started with things around, because in the ITF we don't see any way forward. For those who don't know, in the TLS working group, we have the formal requirement for formal analysis, and we need something formal in order to do the formal analysis. So if we keep talking about CSP is untrusted, definitely this draft is not going to proceed any further, because that's an attack from a formal perspective. Whatever arguments you present, so that's is only under the case that we have some trust in the CSP. But we need to progress this work forward, and the only way I see is, let's say, if not one, let's have two threat models, but find some way out for us to proceed forward in the ITF. This work is not going to proceed without that, or otherwise we should decide in the CCC to just throw away this project, not work on this anymore. And for me, that's fine. So maybe not for the proposers, but I was also one of the supporters for this in the beginning, and I mean, we have to find some way out for this work to proceed, and that's the question I have in my mind. That is there something we can do with the threat model? Can we propose something to TAC that this is a technical problem, this is unsolvable, and this is the only way to solve this is to refine the threat model. Don't say that CSP is completely out of the trust computing base.
I still push back a little bit on changing or having something that doesn't include this diversion attack being different than saying fully trusted, because I just this is the desired and expected behavior of a CSP that you're calling an attack. But I think what we need to do perhaps is in the vein of what we were discussing last time, at least what I was posing last time. So obviously I agree with it. I don't know if anybody else thinks about it, is like there being like a different model. Like there is, I think what you're assuming that you have the expectation of your workload landing on a specific physical machine versus you have the expectation of your workload landing on an equivalence class of machines. And a movement within that equivalence class is not only not an attack, it's a desired feature of the cloud.
So that's my question. So how do you define the equivalence class? So what would be, let's say, a more, can you give me some more details of what you call as the equivalence class?
So an example of an
Why they're
equivalence class.
saying I'm renting type 1 VM, right? Or like whatever you
Yes.
have on these classes on the page.
Right. Like in GCP, we have different machine types. You know, I expect to be landing on an N2D machine type, which is like you know, a specific generation of S&P functionality. And if I'm on a different generation, or it has a unacceptably old firmware microcode, that could change it. I mean, the relationship that the client considers an equivalence class is really about their attestation evaluation policy. If the things they care about are, it has to have this general technology, it needs to be at this particular TCB level, and it needs to be in this region, those three things make up their equivalence class.
So how do you find the region, that which region it is? TCP level and machine type, I can agree on that. So that's a part of attestation. But how do you find the TCP region associated with the the region associated with that device? That's not provided by any protocol, right? How do you know which location it is located in?
Can
I
I,
mean,
can I throw,
the
can I,
region definitions are a concept that is made up by the cloud service provider. So I mean, they are the source of truth of what is a
So
particular.
so you trust the CSP for providing you that. That's my point, right? So you are
For
trusting the
concepts that only make sense for the CSP to make up, and they are the source of truth, then yes, you're trusting the source of truth for that data.
but I want to pitch in there, right? Because you also trust the CSP that it's not just some random machine on the street where, okay, why would a machine on the street be
Yes.
bad? But it's like, it's the same thing. You trust it to be in the building, but behind some logs, etc., right? So there's definitely like a part of this where you trust the parameter.
So that's what I'm calling as fully untrusted, as an unrealistic model, right? So you are trusting them for availability, you are trusting them for regional location, you are trusting them for like even the firmware that's not available to you, and so on. So many things, that's already a lot. So how can we actually claim that to be
Well,
fully untrusted?
I think the firmware aspect that is in scope. Like the fact that that's not universally a satisfied requirement that could represent a potential vulnerability. I think that's in scope. I think that's something that's fair to call out, because it's something that's verifiable.
So
Just conceptually, the things like the region that you're in is not verifiable outside of the source of truth, which is it's a made up concept by the CSP.
So that's another way of just saying that basically you are trusting the CSP, right? So the source of truth is your attacker, right? So saying it, what I'm trying to say is that fully untrusted means that you are trusting your attacker to provide you some information that's important for you for regulation perspectives, and that's the problem I have in order to fix these things.
I'll put my hand up in the back of the line and let other people go for a minute.
Yes,
Whose
please.
hand was up next?
I think I was the next hand. I'll try to be
Yes.
quick. If Osama, can you go back to the diagram with
Yep.
the colored boxes? So it says here at the top, AK of a specific machine it says may be compromised, but we're talking about a scenario where it is compromised, right? And then, right, so that's the assumption here. Is the assumption that that says that the TE technology from a particular vendor has been defeated. That's what it says to me, right? The AK should be protected by the TE technology. So if are you saying it's been compromised in such a way that attestation of that AK does not detect that it's been compromised? Because if that's right, there's the whole value prop of part of the value prop, right, of the TE technology is that, if it's been compromised typically because there's like some bug in the firmware or something, the remote attestation process will catch that, oh, this isn't running up to date firmware, so you know, that this thing shouldn't be trusted because the AK could have been leaked, right? Because of this firmware bug. Are you saying that this is compromised in a way that the TEE attestation process as supported by the hardware vendor cannot detect that the AK has been compromised?
Right. So that's one assumption that we have. You are right.
All right. So if that's the case, forget TLS. The whole anything built on this technology is dust, right? It's just gone. You can't trust anything. It's
That,
just, you know,
that equivalence class of
yes,
machines is not trustworthy. Yeah.
yep. And you don't even know it because in your assumption, it's like it's done in a way that nobody can detect it. That's kind of a, if that happens, it's like everything kind of collapses. You know,
But
nothing
let me put one argument on the table as well. So let's say foreshadow was not done by, let's say, these nice researchers. It was assumed that this was done by, let's say, our adversary. I'm not naming any
Mhm.
CSP, but let's say, so that's if according to this threat model, that's our adversary, we should treat it like this. Why would the adversary be kind enough to tell you that, hey, I have actually compromised this thing?
Well,
You know,
what you're saying to me is
we have
essentially unknown
firmware.
zero-day attacks against the TEE. If they exist, they can take it all down. And that's just the true statement, I think, right? Unknown attacks against any, you know, security technology, including a TEE, you know, they can take it down. And you don't know if they exist or don't exist. If you know they exist, then the TEE vendor hopefully quickly gets involved and, you know, does something so that the attestation evaluation process will be able to eliminate that threat. But when they're not even when those attack vectors aren't known and understood and can be addressed by the security vendors, then it's yeah, I mean I'm not this is not a TLS specific conversation, right? This is anything protected by a TEE. If the TEE can be compromised in a way that's not detectable, then yeah, everything that's based on it is at risk. So I guess from a threat model perspective, to eliminate this attack, right, you have to just say you trust that. I'm thinking on the fly here, it may not make any sense, but is
I
it
mean,
that you trust the TE vendor to basically ensure that this attack is not possible? And if it is possible, then maybe it's not a trust thing. It's um, just the realities of complex systems and things are, you know, ultimately attackable with enough effort.
this is
So
the whole like TCP recovery situation is built into this and the reason why the attestation includes a particular level of TCP is because of this sort of thing, because
Hmm.
it is expected that the technology will have flaws found in it, they'll be patched, and then you don't trust the old version anymore.
right. So I want to point out one thing that's related to something you said, Greg, that you said you kind of mentioned that this is independent of TLS. I would say no, because there are some protocols. For instance, the new internet draft that we have can actually cover some of the attacks. It can at least avoid going to anywhere in the world to a specific let's say data center. So, and we can identify the identity of that specific thing.
But
So that's at least limiting to that
let
thing.
me say, I'm not sure because go back to that diagram, if you
Yeah.
would.
Yes, sure.
You had one is green, one is orange. Since you don't know how
Mhm.
orange happened, how do you know green is green? You never know green is green. Once you say
So
it, it can be orange and I don't know why, you can never know that one is green.
this is different from the one that I was mentioning. So this is within the CSP. So the one here, CSP is the one who is assigning the identity. You are completely trusting
But
it to do that.
but
So
uh,
the point I'm
I'll
making is a bit different.
mhm,
Let me maybe say one sentence quickly. So
mhm.
so the thing I'm saying is that let's assume this was the boundary of CSP, this was outside, and this is some state agency which controls this machine. And with some protocols, for instance, like both of those, TLS attest and interoperable RATLS, both SIG projects, it's really possible that you can divert it to some controlled machine, and it can provide you this evidence because you don't know that it has been compromised. That's the point I'm making. It's not completely independent of the TLS. It's really dependent on the protocols that you actually use for doing this
Yeah.
kind of.
But the
it's-
point I'm trying to make is that once it's possible to once you acknowledge it's possible to compromise a TE environment and it's not caught by the attestation process, you can't trust any of these environments. It's not because, oh, this is one that was, over in this, building over here where this set of folks, compromised it. It's like those set of folks or whoever they talk could go apply it on, pick any machine in the world with that TE technology, send that set of folks over there and they go compromise it. So there are no green rectangles. And understanding, trying to say, I'm ensuring that we're working with this subset of rectangles in my use case doesn't solve the problem of if you take the people or the knowledge of how they compromise the one and share it with people who can touch the other rectangle, that other rectangle can be compromised. So to me, it's the same, right? And that's the way that the industry recovers from these things once it's understood, as they do firmware updates and the attestation process catches the rectangles that are not running up to date code that preclude this particular attack.
Right. So
Maybe we move down the hand list.
yeah,
Mark
sure.
or Ari? Who was next?
Ari is muted.
I just wanted to say that quickly that I agree with you, Greg. I think that this is yet more evidence that the choice of precise threat model is really important, because I think it sounds like you're articulating a threat model that's basically like, compromises of the TE is out of scope, because it's basically you're assuming that if one is compromised, they're all compromised, which is totally reasonable. So that's one threat model. But you could imagine a threat model where you try to split things up, like, assume that, you're talking about a hardware attack or something, that there is some cost associated with compromising an enclave. And so you could imagine a different one where if you cared about that sort of threat model that distinguishes between different enclaves, that you may try to do something different. There's another example that maybe, there's a temporal aspect to it. Like you trust the cloud service provider at time T, but not at time T plus delta. That's what all these sort of transparency log type things, are trying to accomplish, in part. So I don't know how much of this actually falls under TLS specifically, but you can slice things a lot of ways.
I like the perspective that you have, and actually, I think that's a nice way to go ahead, because if we have at least two models, that one says it is fully untrusted, that is the compromise of TE is out of scope, that's fine. As long as we have the other model which is saying that yes, it is possible, like saying that no. So the attack we have is that all the confidential computing machines anywhere in the world have to be running, no machine in the world is compromised, in simple words. So that's the threat model that this has, because there is no identity in some of the protocols that is checked. It could be moved to anywhere in the world and under the control of anybody in the world. And that's the problem that we want to highlight, that it's actually not good. And having another complementary or maybe an alternative threat model where this is possible, and in that case, which is much more realistic, I believe. So we like these attacks have actually been shown that they exist, and I think then at least we can proceed with this draft, that okay, so we are following not the fully untrusted threat model, but we are following this threat model in which some compromise can happen. And in this case, these kind of cases are accounted by default. That's a part of the threat model. So I think we can make progress this way, that we have at least 2 threat models which are well defined, and I see that as a good way. So you mentioned also about the temporal perspective. That was the next point that Jim made. So I will come back to this, and hopefully Jim is, if Jim is in the call, we can come back to this one. Okay,
real quick before you go on with the presentation, I had one more comment on the earlier bit.
Yeah.
I think to put a different verbalization of the like cloud region point of view, I think what I was trying to express is that the cloud region that a machine sits in, because the source of truth is the CSP, it is tautologically true that if they say it's in a region, that it is in the region. So I don't think there's an attack there. Like the definition of whether or not a machine is in a region is if the CSP says it is. Now, if what you are trying to prove is that it sits within some geographical bounds, that's not something that's claimed in attestation. So I think this is a little different on this one. That's why I kind of treated it different, is because like the cloud region that it's in is a statement that is its ground truth is the statement that the CSP makes. And that's very different than the rest of the claims with related to like the type of machine it is, the level of firmware, the TCP, all of this. So.
Right. So my point, Keith, here is only that under this threat model, your the only source of truth that you have is your attacker. And that's what I have trouble against. So it doesn't make sense to me to.
There's not an attack, I think, is related to it that I'm saying, related to that region bit. There's an attestation attack.
So you think that should be added to attestation? Is that something that you want to say, or what?
I think if you wanted to have, if you wanted the attestation to include like a GPS measurement that's rooted in the CPU chip, like that's a different class of hardware than we currently provide. But short of that, like this statement that's being made on cloud region, like what you are getting is a true statement from the CSP.
But I would rephrase it differently. I would say I am trusting my attacker, my dear attacker, to say that it's actually in the region that I expect it to be. I mean, my only source of truth is my attacker. And that's something that I don't feel very comfortable with. I don't know about other people in the SIG. But I would like to be convinced on this. So having an attacker providing you something that you need for regulation perspectives, I think is something that I haven't found a good answer to, and I'm looking for something more than that on this. Okay, so Mark.
All right, so I've been listening, and I want to perhaps inject a little bit of like real world perspective into this. So when it comes to the use of CSP, and when it comes to figuring out, do we want to trust this CSP or not? So what happens in the real world is there is, I believe, like a SOC 3 audit. And once a year, we make sure that every one of our CSPs has passed this audit, and there is a level of truth that can be inferred from that. Then I want to make a sort of a distinction, and this, by the way, dovetails nicely with this whole trustworthy workload identity business, where ultimately what you care about is if a workload presents a credential and the credential contains a set of claims, you would like to be able to trust the issuer of the credential, and you would like to trust the claims in the credential. And not all claims are going to have the same issuer ultimately, and not the same level of trust. And some of the trust can be contractual, and some of the trust can be hardware-based. And the distinction is not necessarily going to be evident in the credential itself. It may be a policy-based decision. So to make it a little bit more concrete, If my workload claim says, for instance, that I would only issue this credential if it was this code running on this particular CPU in an accepted configuration, well, clearly you're going to trust some kind of verifier that examines the claims, and then you need to establish your trust in the verifier somehow. Perhaps the verifier has a TLS certificate issued to it that you're contacting the right verifier, right? And then further down the line, you go to an identity provider and get some credentials from that. So there is a level of trust establishment with that. When it comes to then another claim in the workload identity credential, that would be, say, location. Then for that claim, we would trust the CSP even if we don't trust the CSP with the verifier. So, I can see a situation where I host my own verifier in trusted execution environments that I completely administer and maybe only trust the cloud service provider to, give me network storage compute. Right. But then when it comes to a discussion, all right, and I'm combining now my T-based attestation with my TPM-based attestation to tell me which geographic region this workload is running in. Well, I'm not going to have my verifier vouch for this because I can't, but I will trust the CSP to tell me what it is because we have a contractual relationship, because there may be monetary policy, penalties for that, because they may fail their SOC 3 audit if they're found to be, malicious or whatever, right? So, once you actually go to that level, a lot of these are just policy decisions. And sources can have various levels of trust. But certainly, I'm not going to trust the CSP for telling me necessarily what my workload identity is, and I will not trust my verifier to tell me what the workload location is.
Right. So the summary of that is basically you still need to trust the CSP for location.
For some of the claims. For some of the claims, I'll trust the CSP. For other claims,
So
I will not.
what does that sum of the claims include?
Well, I'm not going to give you the transitive closure, but I will tell you generally stuff about the workload, stuff that T can measure in a quote, like, what code pages the workload comprises, what,
So
data.
what is it? So can you give me maybe concrete example other than location?
Well, I could tell you, let me think.
I think anything that's configured, like, like a virtual machine name, or a virtual machine identifier number, that kind of thing. Like that's a concept where the source of truth is the
stuff that's measured by the TPM, basically. So, for instance, I do not necessarily trust the virtual machine in which my enclave runs, but I would like, as a safeguard, to know that the PCR something in the TPM tells me that it was booted with particular kind of firmware. That I don't necessarily trust it, but I would like to also that additional safeguard, right? And I could trust the CSP to attest my TPM correctly.
But then there is okay. I will come to that later on. But okay. So we have VM identifier number. Is that correct, Keith?
That is another example of one.
But as I said, anything that a quote is measures, I would trust the verifier for. Anything the TPM measures, I would trust the CSP for.
Right. And can you give maybe more concrete examples of what the TPM would measure, other than the
just
ones
have to
that
go
have
what's
been
extended
mentioned?
into the PCRs of a TPM.
What's the typical use case you talked about industry?
Well,
right?
so as I said, like firmware bootloader, like the entire early boot sequence that the TPM or the virtual TPM measures. Like if it's a virtual TPM, I may actually need to trust the cloud service provider that they're securing the endorsement key of the virtual TPM properly. Like
but I don't think that this makes the guest firmware and bootloader like out of scope of this problem, because those things can be measured by the CPU as well. Like it's not intrinsically something
not the early the CPU is not going to measure the early boot measurements of your VM necessarily. right? So
The
stuff
guest
regarded
would
to the
be?
physical hardware, sure, but the guest, I don't know if the TVTs measure that.
You're talking about the guest firmware and bootloader, not the host?
Both?
Because it definitely can measure the guest.
Yeah, but I'm basically saying you need to look at the claims in the resulting credential, and the different claims, they'll have basically different levels of trust and different sources of trust, right? And then you're going to, yes, you get to decide. It's a policy decision who you trust for what.
So I agree with that last bit. I just which things are included in that category. I have a little disagreement on. Like the things that I would put in this category are the things that don't have any meaning other than what the CSP assigns to it. Like what the measurement of the firmware or bootloader is, that has an objective truth to it.
Yeah.
Right. What the identifier assigned to a VM has no meaning besides what the CSP says it is.
Right, and
That
CSP may itself map it to things like location.
It absolutely could, but
and then
like
you have to
that
trust
is
the CSP. And that's, by the way, not only do you have to, it's perfectly okay from a from a typical regulated customer perspective. If you're that paranoid that you cannot, you build your own data center.
Right. Okay, so who's next?
I think we've worked our way through the hands.
Okay. So yeah, then I will proceed to the last thing, which was about the temporal. And I'm not sure if Jim is in the call. And the question that he had, in my understanding, was that this something related to temporal perspective of this, that how was PubAK initially trusted and now, the PubAK2 initially trusted and how it has become untrusted. Jim, is that a good phrasing of your question? And is he in the call? Maybe someone can see. I have only one screen.
I do not see him in the current list of people.
Okay, then maybe we discuss some other time. So that's what I wanted to clarify, if this is what he means, because in that sense, so the discussion that we had was then this could be like compromised at different point in time rather than at the point then it was trusted. So that's temporally different from being trusted at this point in time. It will remain trusted until it knows that by some means, by some magic, that it knows that it has been compromised. So that was something that I had in mind for discussion. So I think that's it. So I will stop sharing.
So that temporal stuff will probably, so in the trustworthy workload identity, we can probably handle that via provenance, right? So in the issued credential, there'll be some kind of a provenance identifier. All of this is very, very early days. So I don't have a full specification to share with you, but you'll be able to chase down how was this credential issued, and then that provenance identifier can be used to say, well, it was because we received these measurements and because the policy was such and such. So you might be able to follow the breadcrumbs and say, oh, this credential, we kind of need to refresh it because somewhere leading up to the issuance of the credential, there was something that we now consider compromised. So perhaps,
So do you have any temporal perspective on this? How this would
you have provenance and you
happen?
have the issuance time of the credential, right? So that's the beginning of the breadcrumb trail.
What do you mean by the issuance of the credential? Which credential?
So this is, again, this is workload identity stuff. This is not attestation results now. If you want to limit that to just attestation results, then you would need to.
No. I don't want to go towards attestation results because we have a simplistic model as I was showing. Maybe just quickly, I will show just to describe you what I mean. So the model I have is very simplistic, which is no attestation results. The verifier and that lying party is joined together as one entity. And I believe, and I strongly believe that the subset of the problems that we have when we have these two roles separated together, because then there is a additional synchronization required from a protocol perspective between the three entities. And we have some initial work towards that, but that's already indicating more problems than the ones we have for those. And that's intuitive because you need to synchronize three different entities and come up with some solution, which is a combination of two TLS connections, perhaps, and so on. So that's definitely more complicated. So what I'm trying to understand is when you say credential, does that mean this key or does that mean this attestation key?
I specifically speaking about the credential being a JOT or a X59 certificate that's issued to a workload. And again, that is going to have a deep provenance to it. So
So then
down
you
to the
are
build
only,
chain. And
so
so
you
what that
are,
allows you to do is you follow the breadcrumbs anywhere the breadcrumbs will leave you, maybe down to the build chain, maybe to what hardware was used, maybe what, the versions of software the verifier was running, whatever the
right.
breadcrumbs tell you. And then if
But
anything in that chain
Mark,
is now considered compromised, you know
yeah.
that you need to do something.
So Mark, you are completely out of context. So what we are doing in the SIG is this project and this project.
Yeah.
So the provenance things, the JOT that you mentioned is Verizon project. That's also a CCC project, but not in the SIG. And the other, so the JOT thing is here. So the certificate thing is attested CSR. That's not the one that we are currently analyzing. So we are talking about interoperable RATLS and TLS attest. So
Well,
that's completely out of
right.
context. That
All
JOT
I'm
and these
saying,
things are,
is if you want to know that there was a compromise after the fact that some piece of information was issued as true, being attestation results or certificate or anything else, then you need
yes,
to start down the provenance route.
right. But what I'm saying is just that is irrelevant for the protocols we are analyzing. The thing that you are mentioning, the provenance and all the blah blah blah, only applies if you have these protocols that will help you with that, and not this one. This doesn't have anything to do with these things. It has no JOT. How will you have the provenance of that? It has no certificate. It is a self-signed certificate, and the same applies here. It has no CS certified identity. How will you even start that provenance chain?
Well, if you don't provenance, then probably you can solve your temporal problem.
So you are saying we can't solve our temporal problem. Is
Maybe you
this correct?
shouldn't even bother. Like, is it really important?
So, okay, so I think that needs discussion with Jim on what exactly he meant, but we found that was an interesting perspective, so I brought it up for discussion. But yeah,
Isn't this problem essentially unsolvable? Because you make a decision based on a point in time, and a picosecond after that, circumstances may have changed. And if you were to remake that decision, you may land somewhere else. So I think when you make a decision like this, right, you have to just kind of say pragmatically, how long am I good? How long am I good for relying on the outcome of this decision based on knowing that the world may change? Is it 1 picosecond? Is it 1 hour? Is it 1 day? Is it 1 year? But if you say I can never, ever, ever be wrong, and I insist that, between making the decision and taking action on the decision, that the decision, that the logic that went into the decision cannot result in a different decision, you can never take action, right? Because there's some time that has to, go by between when you evaluated and made the decision and when you take the action. So and I think there's not one technique for essentially tracking like a possible update to a decision. I think Mark is speaking out about one option, and I think like if you just like look at X509 certificates where you can use things like revocation lists or OCSP to basically answer the question like, is this certificate no longer trusted, right? And you periodically have to go back and check based on how much risk you're willing to assume. 1 week, check the certificates, 1 day, 1 month, things like that. At least that's what this sounds like to me.
yeah. So Greg, my point here is just that if you don't have the CS signed certificate, So all of that is not possible, right? So if the protocol does not include a CA signed certificate, how would you do all of that? So that's the trouble that I'm having in understanding this. I mean, the protocol I am analyzing, both SIG projects, do not have anything to do with the CAs. So how can I bring in new thing from myself that in the protocol analysis I'm having real difficulty
Well,
in
if you're dealing
exporting?
with remote attestation evidence, right, you have to do a verification of some attestation evidence before, right, as part of setting up this channel. And that I think what we're
Right,
talking about, like in this example, is at time one, the TE vendor says AK is trusted, and at time two, the TE vendor says AK is not trusted. And that attestation evidence has typically has certificate change behind it and has mechanisms, be it TCP recovery or what have you, to basically or device revocation mechanisms, has ways to tell you that things have changed. So it's not in the certificate for the TLS conversation. It's in the 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 structure of the attestation evidence from the TE vendor, and and their mechanisms for basically up telling you how things change over time.
If I may
right.
interject, we have 3 minutes left, and we have done zero discussion on trustworthy workload identity and how the two SIGs may collaborate. So if I just may make a short pitch.
Sounds good to me.
All right, so our biggest deliverable is going to be for the next IETF for the WIMZ working group, and the deadline for that is for us to complete our work around roughly June 17th. And what we're doing immediately, we just decided, is that we're going to look for documenting all the mechanisms that we can think of for integrating the verify role and the identity provider. So the different types of dances that can happen, the workflows, the interaction diagrams, again, who issues what claims, what happens if there is a TPM-based attestation versus T-based attestation, how they get combined on the client, on the attester, and how the verifier and IDP may collaborate. So, that's our first order of business. We're meeting weekly, and we very much solicit participation and inputs into that so that we can put that into the set of use cases that we'll be presenting to the IETF and also the basis of our reference architecture.
I provided
do
some
you-
feedback at the IETF. Did you manage to take care of that?
One of the feedbacks I remember you said was that the RATS RFC is not a formal specification. I remember you saying that, and I do not know if we're going to be going the formal specification route just yet, but we definitely want to have interaction diagrams to at least understand who is talking to whom in what order, and from there we can, go to be as formal as possible. But the important bit to get going was to make sure that the IETF accepts our collaboration and has, understands what our requirements and goals are.
Okay, there were other points, but yeah, we can discuss offline. Thanks.
Okay.
do you want to post a link or something to your scheduled meeting so folks know
It's
how
on
to get?
it's on consortium's calendar every Tuesday morning Pacific time. So if you're in Europe, it's going to be afternoon. But that's where you can get your all the information, or shoot me an email, and I will provide you all the details and links.
All right, sounds great. Thank you, Mark.
Yeah, we definitely want participation from the CSP, so specifically Google, Microsoft, to know that we're on the right track, that it can work with your offerings. Right. So.
All right, sounds good. So we're out of time. Thanks everybody for participating today. Mark, from your perspective, is there any follow-on discussions you want to have next time in a couple weeks, or with this announcement, do you feel kind of wrapped up for the moment?
So I want to make sure that we move quickly because our deadlines are pretty strict. We meet weekly. So if you can come to our meetings, and then I'm happy to present the results from TWI in this forum as often as you'll have me.
Mm-hmm. Okay, sounds good.
Mhm.
Osama, do you feel like there's anything more that you wanted to do on this topic? It feels like we're kind of from my perspective, feels like we've kind of have everything kind of on the table, and I think all angles kind of discussed. Um, do you, do you agree, or do you want to reserve some time in a couple weeks?
Yeah, I think we have sufficient discussion. We have done sufficient for now. So probably when we have other updates that need some discussion, we will come back. So for now,
Okay.
we would like the SIG to consider coming up with a secondary threat model with which we can proceed in the IETF for the drafts.
All right, sounds good. Okay, thank you, everybody, and talk with you all in a couple weeks.
Thank you. Bye.
Looks. Bye bye.